Hello everyone, and welcome. I'm excited to have you here today for this presentation on best practices for real apps. We'll be exploring visual diagrams, practical examples, and core animation APIs. Specifically, we'll look at what animations are available in Jetpack Compose. In this session, you'll discover how animations in Jetpack Compose are simpler, safer, and more powerful compared to traditional XML-based animations. Remember, animations are what make your app feel alive and engaging. So, let's dive into Jetpack Compose animations and see how they can elevate your app development experience. Let's talk about animated UI updates. When a state changes, the system automatically handles the animation, making the transition smooth and engaging. This process is called Compose recomposition, which occurs whenever there's a user action that triggers a state change. Essentially, the sequence goes from the state changing to recomposition happening, and then an animation is played to reflect that change. The core idea here is simple. When the state updates, the UI updates itself and does so with animation, making the user experience seamless. It's important to realize that animation is just another form of state change. When the state updates, the animation follows naturally. Now, looking at the Jetpack Compose approach, it emphasizes separating UI logic from animation logic. This separation helps keep things clean and manageable. However, managing lifecycle becomes tricky because Compose requires a different way to handle UI compared to traditional methods. In the old system, you'd need XML layouts combined with animator classes. It's quite verbose and complex. When we compare the traditional view system to Jetpack Compose, the difference is clear. Compose simplifies the process, making UI updates more straightforward and reactive. To truly understand this, we need to grasp the fundamentals. In Compose, UI and animation logic are decoupled, enabling more flexible and maintainable code. This shift in approach is a key part of modern Android development, aligning with our overall goal of creating more dynamic and responsive user interfaces. So with Compose, you simply change the state, and it takes care of the animation automatically. On this slide, you can see some of the properties that you can animate, like alpha, rotation, padding, size, and color. This approach is especially useful when you want to animate a single UI property, such as the color of a button. For example, imagine you have a Boolean state called isSelected, which you remember and update with a toggle. Then, you use animate color as state to animate the color from red to green, depending on whether isSelected is true or false. When the button is clicked, the state flips, and Compose smoothly transitions the color between these two states. The button's background color updates automatically, showing an example of a color change button. When isSelected becomes true, the color turns green. When false, it reverts to red. This all happens seamlessly thanks to Compose's automatic animation handling. What's happening here is quite straightforward. A simple UI change, a single property animation, and a smooth transition without extra effort. So, when should you use this? The key is when you want to animate just one property at a time, using animate asterisk as state functions. It's a powerful way to add subtle, natural animations to your UI with minimal code. Now, let's talk about offset in a DP-based context. Offset typically refers to the position shift of a component, and when working with DP units, it allows us to control how far something moves or is placed on the screen. Next, we have padding. Padding is the space inside the boundaries of a component, giving us control over how much space there is between the content and the edges of its container. It's essential for creating visually appealing layouts and ensuring elements don't feel cramped. Moving on to size, height, and width, these are fundamental properties that define the dimensions of a component. Adjusting these allows us to tailor the UI to fit our design needs precisely. Now, a key concept here is animate DP as state. This function is used to smoothly animate DP values, making transitions feel natural and fluid. For example, consider this code snippet. Val size by animate DP as state. Target value equals if isSelected 200, DP else 100, DP. Here, the size smoothly transitions between 100 dp and 200 dp depending on whether an item is selected. This creates a dynamic, engaging user experience. Finally, linking it to our overall theme, animations like these enhance interactivity and visual feedback, making apps more intuitive and appealing. Whether adjusting size, position, or spacing, using Animate DP as state helps us animate these properties seamlessly. And in the example with the box, we see this in action. The size is animated, and the background color is set to blue, which highlights how these animated properties come together to create a smooth, polished UI. So moving on to slide 5, let's dive into some examples of Spring animations. Here, you can see we're using a damping ratio set to Spring, damping ratio medium bouncy. This creates a lively, bouncy effect, which is perfect for adding a bit of personality to your UI. Now, in terms of animation styles, there's no animation at all, just a snap. But you can also customize timings with keyframes, allowing for more complex, nuanced animations. And of course, a bouncy UI is a classic use case for Spring physics, giving your interface a lively, responsive feel. Spring animations, like the one we've just discussed, provide smooth, default animations that feel natural and appealing. They're great for things like toggles or bouncing effects. On the other hand, tween animations, which you'll see later, are perfect when you need more control over timing and easing. Speaking of use cases, Spring animations are ideal for adding a playful, dynamic touch to your app, making interactions feel more organic. Now let's look at a specific example with the animation spec parameter. Here, we're using a tween with a duration of 600 milliseconds and an easing function called fast out slow in easing. This easing creates a quick start and a gentle slowdown, making the motion feel more natural and pleasing to the user. Finally, under common specs, we see that animation parameters like these are essential for defining how your animations behave. They help ensure consistency across your app and can be tailored to fit the mood or style you're aiming for. To sum up, understanding these different specs and how to customize them allows you to craft animations that enhance user experience, making your app feel more polished and engaging. Now let's take a look at some common UI elements like tooltips, bottom sheets, error messages, and snack bars. These are essential for providing feedback and guiding users through our app. Moving on, one of the most powerful features in Jetpack Compose is the ability to show and hide UI components with smooth animations. Here's an example using animated visibility. You can see that when is visible is true, the content appears with a fade-in and vertical expansion. When it's false, it fades out and shrinks vertically. This creates a seamless transition, making the UI feel more natural and engaging. This technique is particularly useful for things like showing notifications, form fields, or other dynamic content that benefits from animated transitions. It ties into the overall theme of creating intuitive, responsive interfaces that feel alive and reactive. So, mastering animated visibility really helps us enhance user experience through simple yet effective animations. So, one of the really powerful aspects of Jetpack Compose is that you don't have to manually animate views. Instead, you just change the state of your UI, and Compose takes care of the animation for you. For example, when your content updates, Compose can handle fading in the new content and fading out the old content seamlessly. This is where crossfade comes in. It allows for smooth transitions between two UI states, like switching from a login screen to a home screen. You simply specify the target state, and Compose handles the rest. As you can see in this example, you use crossfade and pass in the target state, and then define what UI should be shown for each state. The beauty of this is that it creates a smooth, polished user experience without complex manual animations. It's all about making UI transitions feel natural and effortless, which ties back to the overall theme of creating fluid, responsive interfaces with minimal code. This approach really simplifies UI switching and enhances the user experience significantly. Now, instead of creating separate animations for each UI property, We can streamline the process by creating a single transition and attaching all the animations to it. This approach simplifies our code and makes it easier to manage multiple animations simultaneously. The key function here is update transition, which is especially useful when one state change needs to animate several properties at once. For example, we start by defining a transition with update transition, passing in the current state, like is selected. Then, for each property we want to animate, such as color and size, we create individual animations attached to this transition. Notice how we animate the color. If the item is selected, it turns green. If not, it turns red. Similarly, for size, it increases to 200 dp when selected and shrinks back to 100 dp when deselected. By using update transition, we ensure that all these property changes happen together in a smooth, coordinated way. This method keeps our code clean and our animations cohesive, which is especially helpful for creating engaging, polished UI experiences. Now let's take a closer look at this example of an infinite animation, specifically the loading pulse. What we're doing here is creating a smooth, continuous effect that mimics a pulsating loading indicator. The key concept is the infinite transition, which allows us to animate properties endlessly without manual intervention. In this case, we're animating the alpha value, or transparency, which oscillates between 0.3 and 1. The animation starts at 0.3, increases to 1, then goes back down to 0.3, creating a seamless loop. The animate float function handles this, with an animation spec that specifies a tween of 800 milliseconds for each transition, and the repeat mode set to reverse. This setup ensures the alpha value smoothly pulses back and forth, giving a dynamic loading effect that feels natural and engaging. It's a simple yet powerful way to add life to your UI components, making them more interactive and visually appealing. Connecting this to our overall theme, infinite animations like this are essential for creating engaging user experiences, especially in scenarios where feedback or ongoing processes are involved. They keep users visually engaged and informed without overwhelming the interface. Now, let's take a look at some common navigation transitions that enhance user experience. These include onboarding screens, which guide users through new features or setups, and expandable cards that reveal more content when needed. Loading shimmer effects are also important. They give users visual feedback during loading times, making the app feel more responsive. Next, we have the like button animation, which adds a fun and engaging touch to user interactions. To demonstrate how animations work, we're using a simple example here. I've created an animatable object called offsetX, starting at 0. When the component is launched, we animate this value to 300f over a duration of 1 second using a tween animation. You can see the movement from 0 pixels to 300 pixels, which we control manually. This is a great example of how you can implement physics-based movement, giving your animations more natural and fluid motion. Users can also interact through drag gestures, which makes the experience more intuitive. These techniques are used for more advanced control over animations, particularly with the animatable class. By leveraging these tools, you can create more dynamic and engaging interfaces that respond smoothly to user input, ultimately improving the overall app experience.